This is hybridization for the MCAT, and follow this page for a lot more almost daily MCAT advice. Starting with SP3 hybridization. The whole reason for hybridization is to explain what we see whenever a molecule has 4 electron groups attached to it. And an electron group can either be a bonded atom like we see here, or a lone pair like we see there. The electrons in these bonds, or in the lone pairs, are all equal in terms of energy. And when we think about electron configuration, and let's take a molecule like carbon for example, its valence electrons occupy the 2s subshell and the 2p subshell. The problem is that has 4 orbitals, but those are not equal in terms of energy. The 2s orbital is lower in energy compared to those 2p orbitals. But when an atom has 4 electron groups and we look at the electrons in those bonds or in those lone pairs, they're equal in terms of energy. So the electron configuration of that atom just doesn't make sense with that. Hybridization fixes this by saying that the s orbital hybridizes with all 3 p orbitals to create a new subshell called the sp3 subshell, and this one has 4 orbitals of equal energy. Now the electrons that are in these bonds or in the lone pairs will occupy those sp3 orbitals. And when you have 4 electron groups, you have 8 total electrons, and all 8 electrons are in that subshell. Also, before we do the next hybridization state, you can check out the link in my bio to find my MCAT community that has hundreds of PDFs that have drawings and typed out explanations like these. SP2 hybridization is used to explain any time that we have 3 electron groups, and those can be bonded atoms or lone pairs. Anytime you have 3 electron groups, one of those atoms is going to have a double bond between it and the central atom. And then one of those bonds of the double bond, and it's the blue bond that I've drawn, will not be equal in terms of energy with all of the other electrons. That leaves us with 3 bonds in this molecule, or in this molecule we have 2 red bonds and 1 lone pair, so in both cases there are 6 electrons that are equal in energy. The way that hybridization explains this one is that the s orbital hybridizes with 2 of those p orbitals. That leaves 1 of those p orbitals unhybridized, which we draw there. All of the electrons that are in those red bonds or the lone pair would occupy the hybridized sp2 orbitals, and there are 6 electrons, so it fills that. And then the electrons in the blue bond, which is one of the double bonds, will occupy the unhybridized p orbital. Since it occupies the p orbital, we call that bond a pi bond. All of the red bonds are called sigma bonds. For sp hybridization, we have 2 electron groups, and these can be bonded to the central atom with a double bond for each electron group, or one of the groups has a triple bond and then the other one has a single bond. You could also have a case with a central atom and a lone pair and then 3 bonds to another atom. If your central atom has 2 double bonds, then 1 bond of each of the double bonds is going to be equal in energy to each other, and then the electrons in the other bond for each of those double bonds will be equal to each other. When you have the triple bond, 2 of the bonds in the triple bond will be equal in energy to each other, and then the electrons in the other bond in that triple bond will be equal to the single bond, or to the lone pair if we have a lone pair. Hybridization explains this one by taking 1 s orbital and hybridizing it with 1 of the p orbitals. The other 2 p orbitals remain unhybridized. The electrons that are in the red bonds or the lone pair will occupy